This is a similar example to one we did a minute ago. Okay, first question. If we add 0.1 mole of sodium hydroxide and the volume of the solution doesn't go above 1 liter, we have basically a 0.1 molar solution of sodium hydroxide. And we know that this is a strong base and completely dissociates to form sodium and hydroxide ions. So this is true. So it might be handy to look at the pOH here. So pOH of 1, and we know pH and pOH must sum to be 14. So pH must be the difference between 14 and 1. And that makes sense because this is a strong base. Okay, now let's get into this problem. One tricky part might be, figuring out what is the base and what is the acid. This stuff looks similar to this stuff, right? But this is a polyprotic acid. This might look familiar. Phosphoric acid loses 1 proton and becomes this, which is kind of an acid still, and it loses a proton and becomes this, which is now kind of basic. So this is going to be the more acidic species. And notice that it is negatively charged, so that it is going to pair with 1 positive sodium. And this stuff is the base, and it has a 2 minus charge, so it's going to pair with 2 sodium, like such. So when we add the sodium hydroxide base, it's going to react with this one, the acid here. How much of that do we start with? 0.4 molar. And since we again have a convenient 1 liter solution, we can say we have 0.4 moles of it. The sodium hydroxide is, we're adding 0.1 moles of that, so we react away 0.1 moles, and we get 0.3 moles left. Now, the product of that reaction is the conjugate base, so we're making the same amount of this stuff. Now that we know the amounts of acid and conjugate, we can use Henderson-Hasselbalch. Now, the Ka of our weak acid is given right here. So to turn that into a pKa, we will take the negative log of it. And when using the Henderson-Hasselbalch equation, we can use a mole ratio as well as a molarity ratio. And we can see that the solution remains very neutral. This buffer was well prepared for the addition of base. But I guess we haven't answered part A. What is the pH of the buffer before addition of the base? So for that, let's just use our values of the buffer before anything went in. And that does not change our value for pKa, but it does change this value. So yes, the original buffer pH was pretty close to what it ended up after we added base.